Now let's do an example. Let's suppose that we have a load of 50 minus J 100 ohms and that's on a 50 ohm transmission line. It's connected to a piece of transmission line that is 2.3 wavelengths long, and I want to add in a parallel capacitor. So the first thing that we do is we normalize. So we take ZL and we divide it by Z0. That gives us 1 minus J2, and let's plot that on the Smith chart. Here is our real part of 1. Down here is 1, and there is 2. So this value right here is Z load. The next thing that we're going to do is figure out where we are, because we're going to need to rotate a distance 2.3 wavelengths towards the generator. So let me take my piece of paper and draw from the center of the Smith chart out through the point that I'm interested in, which is my point, just like this. And let's read off that value. Looks like that's about 0.31 wavelengths. I want to go 2.3 wavelengths towards the load, so that's going to take me to 2.61 wavelengths. Well, we know that every circle, every time we go around, that is 0.5 wavelengths long. So I can eliminate this 2 because we don't need to go the full 2. By the time we've gone around once, that's a half. A second time around is 1. Next time around is 1.5. Next time around is 2.0. So I need to go to 0.61 wavelengths. So let's see, here's 0.31, 0.35, 0.40. Right up here is 0.49, and then it goes to 0. That's the same thing as being at 0.50. Now let's find where the 0.1 point is. That is right there. So that's like being at 0.6. And then this point right here is like being at 0.61. So I'm going to take my straight edge and I'm going to draw from the center of my Smith chart out to this point that I'm interested in, just like that. And that's going to be point A. So I need to take my distance and copy it up here. So mark from here to here on your paper, and then copy it right here about like that. This is going to be my point ZA. The moment it's still in impedance and it is still normalized, so I'm going to read it off the Smith chart. Let's read the real part. Looks like that's about 0.35. So actually, let me write the steps that I've done here. The next thing that I did was rotate 2.3 wavelengths towards the generator, and I removed the 2.0 because it's an even multiple of 0.5, and so I actually went 0.3 wavelengths towards the generator. Now that gave me the point ZA, and I'm going to read it. The real part is about 0.35, and the imaginary part is positive because I'm up in the top part of the axis, and it's right there. That's about 0.8 plus J 0.8. Now I need to denormalize, and the way I'm going to do that is I'm going to multiply by Z0, which is 50 ohms, and that's going to give me the value of ZA in ohms. So that gives me 17.5 plus J40 ohms. Okay, so now I know ZA, but I want to add in a parallel element, so I need YA. So the next thing that I'm going to do, in order to get YA, I could either do it with my calculator, and I could say that it's 1 over ZA, or I could just take my straight edge and translate the ZA value through the center of the Smith chart like this. Mark my point right here, mark my other point right there, and this is the value YA. So I'm going to read YA, which has a real part right here of about 0.4, and an imaginary part which is negative J about 1.2. In order to get that in mhos, I need to multiply by Y0, which is 1 over Z0. Then the next thing that I need to do is calculate ZC, or YC rather, because it's in parallel, which is J omega C. And in order to find YN, I'm going to just take YC and add it to YA.